everyone, myself K. Niranjana from second year CSE department. Today I am going to present topic about thread. First I discuss about introduction to threads. A thread is like a small task inside a program. Example, when you browse the internet, one thread loads the web page, another downloads the files, and another responds to the user clicks. Next we move on to what is a thread. A thread is a lightweight process that runs inside a program. Multiple threads share memory but execute tasks independently. Example, MS Word uses one thread for typing and another for spell check and another for autosave. In most commonly, thread is a lightweight process. It is very important. Next we see the difference between the process and thread. Features, memory, speed, communications. In process, memory, it separates the memory. In thread, it shares the memory. In future speed, the process is slower and threads is faster. We see the example of memory, running Chrome and Word separately, and for thread, multiple tabs in Chrome. This is the difference between the process and thread. Process means running Google Chrome and MS Word separately. Thread means different tabs inside the Chrome running separately but within the same process. Next we discuss about type of threads. There are two types of threads, user level threads and next kernel level threads. First we discuss about user level threads. User level thread means controlled by software, not the OS. And it is fast but cannot use multiple cores. For example, Java threads inside a Java applications. This is the features based on user level threads. And next we see the kernel level threads. It is controlled by or managed by the operating system. It is slower but supports multiple core processing. Example, Windows, Linux system threads. Next we discuss about what is multithreading. Multithreading means running multiple threads at the same time to improve the performance. It is called multiple threading. Why we are using multiple threading means makes program faster. It uses the CPU efficiently. Helps in real-time applications like gaming and web service. For example, a video player plays the video, loads the subtitle and processes audio using the multiple threads. For benefits, it increases the CPU utilizations. It enhances responsiveness and next efficient resource sharing. And next we move on to the multithreading modes. Multithreading modes define how user threads communicate with kernel threads. There are three models. First we discuss about many-to-one model. It uses multiple user threads to one kernel thread. Problem means if one thread blocks, all stop. For example, early Java virtual machine JVM is the best example. Okay. Disadvantages is if one thread block means it stops all the thread stops. So it is the disadvantage of many-to-one model. And next we see the one-to-one model. One user thread, one kernel thread. Advantage is true parallelism. There is a problem and disadvantage. What it means, uses a lot of memory, high memory consumptions. For example, Windows, Linux, POSIX threads. This is the example of one-to-one model. Each user thread maps to one kernel thread. And next we see many-to-many model. Many user threads, many kernel threads. Advantages, efficient, balanced speed and memory usage. For example, modern Linux system, Solaris OS. Multiple user threads maps to multiple kernel threads. Advantage, balance, flexibility and efficiency. And we discuss about thread lifecycle. There are 5 lifecycle. New, that means thread is created. And next ready, waiting for CPU time. And next running, actively executing. And next blocked, waiting for resource, examples like waiting for a file. And next terminated, task is completed. This is the thread lifecycle. Example, in MS Word, when you type, the thread is running. If it waits for a file to save, it is blocked. It is the best example for thread life cycle. And we discuss about thread synchronizations. There is some issues. What means threads share memory leading to conflicts. If multiple threads access the same data at the same time, causing conflicts. This is the problem. There is some solutions. Use synchronization techniques like mutex, mutual exclusions. For example, in online banking, two people cannot withdraw from the same account at the same time. The system uses locks to process one request at a time. This is one of the best example for thread synchronization. And we next move to the threading issues. There are three conditions. First, race condition. Two threads try to change the same data at the same time. And next, deadlock. Threads keep waiting for each other, never finishing. And last, starvation. Some threads never get CPU time. For example, race condition. Two people editing a Google Doc at the same time, causing a text conflicts. Deadlock means one thread is waiting for a file while another waits for CPU and both never process. So it is the example for thread issues. And next we move to the thread pools. What is thread pools? Instead of creating new threads, the OS reuses the existing threads from thread pool. There is an advantage. Save memory one time. Used in web servers. Another advantage is prevents exclusive thread creations. For example, web servers use thread pools to handle multiple client requests efficiently. So this is the example for thread pools. And next we move to the thread specific data. Sometimes each thread needs its own private data. For example, online shopping app. Each thread stores the details of one customer shopping cart without interfering with another's. Solution: use thread local storage. This is the example of thread specific data. And we discuss about the advantage of the thread. It will faster executions and next efficient CPU utilization, and it supports parallel processing and reduce the memory usage compared to multiple processes. These four are the best examples and advantages for the threads. And we see the disadvantage of thread. Complex debugging, risk of deadlocks, high context switching overload. These three are the disadvantage of the thread. And next we move to the challenges in thread. Thread starvations. There are three challenges in thread. Thread starvations. Lower priority threads may never get CPU time. And next, debugging issues. Hard to track thread errors. And next, race condition. Multiple threads accessing the shared data can cause unexpected results. These are three of the challenges in the threads. And we next see the future trends in threading. There are three threadings in future trends. AI-driven thread management, quantum computing threads, enhanced debugging tools. First, AI-driven thread management. OS automatically schedules thread based on demand. And next, quantum computing threads. Means future computer will use quantum threads for faster processing. And next, enhanced debugging tools. Means better tools to detect race conditions. And next, we see the conclusions of the thread. These threads improve performance, speed and efficiency of programs. And next, proper synchronization is needed to avoid issues. Future trends will make threading smarter and more efficient. These are the conclusions of the thread. Next, we see the real-world application of threads. Web browsers. Threads for page loading, rendering, user interaction. Gaming, like separate the threads for graphics, sounds and physics. OS kernels, background process like indexing, updates and antivirus scans. These are the real world applications of threads. Thank you.